In this experiment, we're going to investigate Coulomb's law. Specifically, we're going to investigate how, as we increase the separation of the two charged spheres, the electrostatic force varies. So we're going to connect, like we did before, the two spheres to a high voltage power supply and charge up the spheres so they both have the same charge. We can measure the force using a top-pan balance because the repulsive force will produce a force on the lower sphere pushing down on the top-pan balance, and that will give us a measurement we can record. We will fix the voltage at a fixed voltage, so we won't change the number of charges on the sphere, but we will vary the distance between the two spheres. So here's the experiment set up, and by rotating the sphere we can screw the sphere up and down, and one full rotation corresponds to 1 millimeter. So we put a mark on the sphere and then we can wind it up, so one complete rotation is 1 millimeter, and we're going to start off with it wound up 4 millimeters, and then we can record the force, and then we can gradually bring the sphere down. So we plug in the power supply to charge up the sphere, and we set the voltage at 3 kilovolts. The top-pan balance has a reading on it, so what we're going to do first of all is zero the top-pan balance so that it shows a value of 0 grams, and now we can turn on the voltage and get a reading. We rotate it quarter of a turn, so that's a quarter of a millimeter, so the sphere is moving a quarter of a millimeter closer, and you can see the reading on the top-pan balance. And we're going to rotate the sphere a quarter of a turn or a quarter of a millimeter each reading, so that gradually the spheres get closer together. There will come a time where the spheres are so close together they could well arc across them, and that will be the limit of what we can do with the experiment.